Hello children, welcome to my class Refraction of Light at Plane Surfaces. In this session, we are going to learn laws of refraction and what is meant by total internal reflection. Let us learn the laws of refraction. The first law of refraction says that the incident ray, the refracted ray and the normal drawn at the point of incident all lie in the same plane. Observe this one. This is the incident ray and this is the refracted ray. This is the normal drawn at the point of incident. The incident ray, this ray and the refracted ray and the normal drawn at this point of incident, they all lie in the same plane, in the plane of paper. This is first law of refraction. Let us learn what is second law of refraction. The second law of refraction is also known as Snell's law. See, for a given pair of medium, the ratio of sine of the angle of incident to the sine of the angle of refraction is always constant. That is, sin I by sin R is equal to constant. This ratio is equal to the refractive index of the second medium with respect to the first medium. This is denoted with n to 1. N to 1, that is sin I by sin R. This ratio is always constant. This is equal to n2 by n1, which is equal to the velocity of the light in medium 1 by the velocity of the light in medium 2. It is always constant. Observe this picture clearly, children. Here I have taken a semicircular glass slab. For normal incident, the angle of incident is equal to 0 and the angle of refraction is equal to 0. Observe this clearly. Children, observe this one. The light rays are traveling from rarer to denser. Glass slab is the denser medium and this is the air. The light rays are traveling from rarer to denser medium for different angles of incident. See, when the angle of incident is 10 degrees, the angle of refraction is 7 degrees. When the angle of incident is 20 degrees, the angle of refraction is 13 degrees. When the angle of incident is 30 degrees, the angle of refraction is 19 degrees. If you take the sine and sine values for angle of incident and sine value of angle of refraction, and its ratio sin I by sin R is always constant. This is equal to nearly 1.5. So the refractive index of this semicircular glass is 1.5. Next, if you observe these values clearly, when the angle of incident is more, the angle of refraction is less. Why? Because the light rays are traveling from rarer to denser medium. Rarer to denser medium means from air to glass slab. Observe this one. So the refracted ray bends towards the normal. It bends towards the normal. Are you clear? Okay. So with this experiment, we can conclude that for a given pair of media, the ratio of sin I by sin R is always constant, which is known as refractive index of the medium. Children, you observe this animation. Light rays are traveling from denser to rarer medium, denser to rarer medium. At a particular instant, when the light rays are traveling from denser to rarer medium, at particular instant, the refracted ray glances over the interface. Observe this one. Okay, so this angle of incident, see this one, this angle of incident, observe this carefully. This angle of incident for which the refracted ray, instead of going into the rarer medium, it glances over the interface, it slides over the interface. This angle of incident for which the angle of refraction, observe this one, this is the angle of refraction, observe this one, this angle of refraction is 90 degrees is known as what we call it critical angle. So for certain angle of incident, the angle of refraction is 90 degrees. At that angle of incident, the refracted ray passes through the interface separating two medias. That angle of incident for which the angle of refraction is 90 degrees is called critical angle and is denoted by IC. See this one. Here the angle of refraction, observe this one. The angle of refraction, observe this. This is equal to how many degrees? 90 degrees. So at what angle of the incident? This is the angle of incident. Okay. This angle of incident for which the angle of refraction is 90 degrees is known as what we call it critical angle. What is that? Critical angle. Children, let us do an activity to verify what happens if the angle of incident is greater than the critical angle. And this activity, with this activity, we also prove total internal reflection. What are the materials needed to prove total internal reflection? The materials needed are semicircular glass slab and a laser light. See this one, a laser light and a pencil and protractor, a drawing board and drawing sheet. Before doing the experiment, fix the white drawing paper on the drawing board with the help of the pins. Draw the two mutually perpendicular lines on the white paper. With the help of the protractor, mark the angles on either side of the axis. Okay, now let us do an activity. Keep the semicircular glass slab in the middle of the drawing paper, and for different angles of the incident, observe the angles of refraction. At a particular angle of incident, the refracted ray, observe this one, at a particular angle of incident, the refracted ray, instead of going into the rarer medium, it glances over the interface. In this experiment, this angle of incident is 43 degrees. If I increase more than 43 degrees angle of incident, the refracted ray totally reflected into the denser medium. This phenomena is known as what we call it total internal reflection. Why? Because the refracted ray reflects back into the denser medium. Observe this one. If you go on increasing the angle of incident beyond critical angle. So what do you mean by total internal reflection? When the angle of incident is greater than the critical angle, the light ray gets reflected into the denser medium at the interface. This phenomena is called total internal reflection. Condition for total internal reflection to take place. Light has to travel from denser to rarer medium. Light has to travel from denser to rarer medium. Next, second one is angle of incident is greater than the critical angle. Angle of incident is greater than the critical angle. In this experiment, the critical angle is 43 degrees. The refractive index of the semicircular glass slab is 1 by sin C, 1 by critical angle, that is sine of critical angle. Here the critical angle is 43 degrees. So 1 by sine of 43 is nothing but 1.5. I think children, I made the concept crystal clear to you. Okay, if you have any doubt, please post your doubts to my WhatsApp number. Don't forget to subscribe to my channel to watch further videos. Thank you, children.